Hello everyone and welcome back. My name is Mr. Covalent, and in this video I'm going to be going over how to classify compounds as either covalent or ionic. So let's get into this. And yes, I have shaved, so this is what I look like when I shave. So I hope you enjoy this video with a shaved look. Okay, so we're going to talk about molecular versus ionic. So molecular, or also known as covalent compounds, are identified by the fact that they have covalent bonds. And what is a covalent bond? Well, that is a bond where you are sharing the electrons between the atoms. Okay, so this is not going to be a complete transfer, but what is also referred to as an incomplete transfer of the electron. So the electron or electrons are being shared between the two atoms. And this is going to happen between non-metals because both non-metals want the electrons. They want to have that octet, right? So if you remember from my previous videos, or if you haven't gotten to that far yet, you'll know that non-metals want to be like noble gases, or actually all atoms want to be like the noble gases, and the noble gases are the group 8 elements on the periodic table, and they have a full octet. They have a full shell, which tends to be 8 electrons, and so all atoms want to be like them. So they're either going to lose or gain electrons. The nonmetals are closest to their noble gases that are in front of them. To the noble gases are to their right, and so they need to gain electrons to be like the noble gases. Your metals tend to be closer to the left side of the table or the center. They're in the center or the left side of the table, and so the closest noble gases behind them, so they're going to have to lose electrons to be like their noble gas. And so uh, for molecular substances, or for nonmetals, right? So if you have a molecular substance or a covalent substance, that's going to be made up of only nonmetals. They both want electrons to get that outer shell full, which is again usually 8. And so in order to appease each other, in order for both atoms to have their full octet, they're going to share the electron. So it's an incomplete transfer of electrons. But you can have either equal sharing or unequal sharing. So if you are equal sharing, that would be like hydrogen H2, where the atoms are exactly the same. So we have two hydrogens bonded together, and this dotted line represents the electron density. And so the electron density is equally shared between the two atoms. One side doesn't have more electron density than the other. And what I mean by electron density is basically where do the electrons spend most of their time? Do they spend it on this side or this side? And it's really equal. So there is not one side more than the other. In this case, HCl, we have hydrogen bonded to chlorine, and here you have an unequal sharing. Here you have equal, and the reason for this is because they're the same atom and the electronegativity is the same. The electronegativity is that ability of the atom to pull on the electrons towards it in a bond. So the electrons in a bond are attracted more to one side or the other. Since the electronegativity is the same for both of these atoms, since they're the same atom, there is not going to be more pull on one side than the other. So equal sharing. This is what we call a non-polar covalent bond. Here, your chlorine is more electronegative. It wants the electrons more. So the electrons are going to spend more time on this side than on this side. So you can see that the electron density here is tilted more towards the chlorine. And this is where we get poles. We get a positive pole and we get a negative pole. Since the electron density is less on the hydrogen, we give that a positive or a partial positive. That delta here, this lowercase delta with a plus, that's partial positive or fractional positive. So this means a partial positive, and this is a partial negative. The chlorine being more electronegative, the electrons spend more of their time over here. They're spending more probability of being over here than over here. So since electrons are negative, this gives this side a negative charge. So this is your negative pole. This is your positive pole, kind of like a magnet. You have south pole and you have north pole. Here you have the positive pole, negative pole. That's why we call this a polar covalent bond. Non-polar means there is no poles. There are no poles on this. So there's no plus side and minus side. So it's non-polar covalent bond. This is a polar covalent bond. And so that is your molecular covalent bonds. And this would be your molecular covalent substances. Now, what about ionic? Well, ionic substances are going to be the ones that have ionic bonds. Well, what is an ionic bond? That involves a complete transfer of an electron from one atom to another. And this happens between metals and nonmetals. So the reason for that is, as I mentioned earlier, is that the metal being on the center or towards the left side of the periodic table wants to lose electrons to be like the noble gases. So they want to give their electrons away. And then the nonmetal wants to take the electrons from somewhere. They want to gain electrons to be like a noble gas. So if you put a metal and a nonmetal together, that's a great partnership because the metal wants to give the electron away. The nonmetal wants to take the electron. So it's going to be a complete transfer. They do not share the electron. So here we have sodium with 11 protons and 11 electrons. It has one valence electron, the electron on the outermost shell. So remember, this sodium wants to give away electron. Why? Because then that electron goes away, and then the next outermost shell is going to be this one, which is full. That's going to be stable like a noble gas because they want to have an outer shell that is full of electrons. And you'll notice that this one has 8 electrons, and so that would be great for sodium. For chlorine with 17 protons, 17 electrons, it has 7 electrons on the outermost shell, this third shell. And so it would like to gain the electron in order to have a full octet, to have 8 electrons. That would give it a full shell. And so it wants another electron. So put these together, you get a transfer electron. They're going to react. And then what happens here, you get what is called a cation, a positive ion. So the sodium lost its electron, and now the outer shell is full, which is the second shell here. So you lost the third shell in a manner of speaking. And so now you've got a full outer shell. Sodium is now happy. It's now got a plus charge here because now it has 11 protons, but now it only has 10 electrons. So there's an imbalance in charge, so it's a plus charge there. So we call that a cation. Remember, cation has a T in it, so therefore T looks like a plus, so plus, positive. So cations are positive ions, and then the chlorine here picks up the electron, and now it has a full outer shell. This third shell is now full with 8, and you'll see it now has a negative charge. That's an anion. Negative ions are called anions. And so here we got Cl minus, and the reason for that is because we have 17 protons, and now we have 18 electrons, and that's because we gained an electron. So now there's an imbalance here. We have more electrons than protons, so we got a plus 1 charge. Here we have more protons, electrons. We have a plus 1 charge here. Minus, did I say plus 1? I meant minus 1 charge here. And so now the ionic bond is created by the attractive force between the ions. So we know opposites attract. So we have a positive ion, positive charge. We have a negative ion with a negative charge. The negative and positive are going to attract each other, and that attractive force between them is called the ionic bond. The attractive force here is the covalent bond, and here the way the attractions work is you got negative electrons being shared between the two positive nuclei. So the nucleus, the positive nucleus of the hydrogen and the positive nucleus of the chlorine are attracted to the electrons that are being shared. The negative electrons are attracting both together. So the electrons in the covalent bond act as kind of a glue. So there's attractive forces going on there. So that's how the bonds are created. But this is a full-on electrical charge here, positive and minus, and that is causing the attractive force. So that's your ionic bond. And so that is the difference between your ionic and your covalent bonds, or your ionic and covalent substances. Usually it's the case that in order to, if you have a metal and a nonmetal together, that's going to be ionic. So if you're trying to determine whether you have an ionic substance versus molecular, as I said, your ionic is going to be a metal plus a nonmetal. If you have a metal and a nonmetal in your formula, in your compound, that's going to be a dead giveaway that you've got ionic. Now, is that going to be always the case? No, it's not always the case. Usually it's the case that you get an ionic substance, and 9 times out of 10, you can bet you have an ionic substance if you have a metal and a nonmetal. And then with there are some exceptions, maybe metalloids. If you have metalloids in there, it could act as a metal or a non-metal depending on the compound. So you got to be careful. But usually, almost always the case, if you have a metal and a non-metal together, that's going to be ionic. If you have 2 non-metals or more than 1 non-metal in your compound, those non-metals are going to be covalent. And so you've got a molecular substance or a covalent substance. So that's it for this video. I hope you enjoyed this video. If you enjoyed this video, if this was helpful in any way, then please like the video, share the video with your friends, hit that like button over there somewhere. And also make sure you subscribe to my channel, hit that notification bell. When you do, make sure you click all so you'll be notified by all the videos I put out. And finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a question you want me to answer, if you have a topic you want me to cover, then please let me know. I would love to do that for you. Thanks for joining me, and have a great day.